Hello and welcome to the AI Research Roundup. I am your host, Alex, and today is June 10th, 2025. We're looking at a research paper from Hugging Face's trending list, published just yesterday, titled Reinforcement Pre-Training. This paper introduces a new method called Reinforcement Pre-Training, or RPT. Essentially, it changes how models learn to predict the next word, or token. Instead of just predicting, the model is trained using reinforcement learning to perform a reasoning task first, and it gets verifiable rewards for correct predictions. This approach helps improve language modeling accuracy by encouraging this deeper reasoning. Okay, so the figure we're looking at now really visualizes this shift. On the left, we see what they call the cherry on top cake. This represents the traditional approach where standard next token prediction, which is how most language models learn to predict the next word, forms the bulk of the cake. Reinforcement learning, often just called RL, where models learn from rewards, is just a small cherry on top, typically used for fine-tuning. But with reinforcement pre-training, shown on the right as a cherry cake, RL becomes integral, baked right into the pre-training by incentivizing next token reasoning. This allows RL to scale to vast amounts of web text. So, building on that idea of baking reinforcement learning right into the pre-training, this figure really clarifies the how. At the top, we see standard next token prediction. Given some text, like electric force grows with charge, the model just tries to guess the very next word. Here, its size, based on its pre-training corpus, which is the huge dataset of text it learned from. But below, with next token reasoning, after the same text, the model inserts a special think token. This prompts it to generate an internal thought process before finally predicting size. This reasoning is what gets rewarded. Alright, so this next diagram really unpacks that rewarded reasoning process. We see the same input text, electric force grows with charge. The LLM then performs what are called on-policy rollouts, which means it generates several different possible thinking trajectories, or paths of reasoning. Each path includes an intermediate reasoning step and then a final prediction for the next token. For example, one path might lead to polarity, another to size, and yet another to and. A positive reward. Here, a 1 is given if the prediction matches the ground truth token, which is the actual correct next word from the original text. Otherwise, it gets a 0. This reward signal then updates the LLM, encouraging those more accurate reasoning patterns. Okay, so this table really shows the payoff of that rewarded reasoning. We're looking at next token prediction accuracy. Basically, how well the models guess the next word across easy, medium, and hard test questions. The model trained with reinforcement pre-training, called RPT-14B, consistently scores higher. For instance, on hard questions, it achieves 23.75% accuracy, beating standard models like QN2.514B and R1 Distill QN14B that hover around 20%. And interestingly, that R1 Distill QN14B baseline model, when trying reasoning without reinforcement pre-training, performs very poorly, highlighting the benefit of this new pre-training approach. Following up on those accuracy numbers, this next figure really illustrates how reinforcement pre-training scales. We see next token prediction accuracy on the vertical axis, plotted against RL compute, which is measured in flops, or floating point operations per second, a common way to quantify computational power on the horizontal axis. There are separate lines for easy, medium, and hard data, and all of them clearly trend upwards. This upward trend indicates that accuracy consistently improves with more training compute, following a power law relationship. The very high R-squared values, which are coefficients of determination close to 1, confirm this strong, predictable scaling. Alright, so building on those scaling properties, this table shifts to zero-shot performance on general domain tasks. Zero-shot performance essentially means the model is tackling tasks it hasn't been explicitly trained on, without any examples. We're looking at two benchmarks here, SuperGP-QA and MMLU Pro. Noticeably, the RPT-14B model, when using its reasoning mode, scores 39.0% on SuperGP-QA and a strong 71.1% on MMLU Pro. These scores outperform both the 14B and even the larger 32B baseline models, underscoring its enhanced general reasoning capabilities. Indeed, those enhanced general reasoning capabilities really highlight the takeaway here. Reinforcement pre-training, or RPT, offers a novel way to build more capable LLMs by treating next token prediction as a reasoning task that's rewarded intrinsically from the training data itself. Models develop deeper understanding, not just memorization. This leads to better accuracy, scaling, and the strong zero-shot performance we just discussed. It's a compelling approach. Thanks for joining me on the AI Research Roundup.